All right, this is the second half of simplifying radicals. So it's 11.1b. Okay, so this time we're simplifying radicals involving quotients. Last time it was simplifying radicals involving product. Now it's quotients. So now we're dividing. Now, some information you need to know. When we're dividing radicals, you cannot have on the bottom of a fraction, you cannot have a square root. So I'll be teaching how to get rid of square roots if it's not a perfect square root on the bottom of your fraction. So, on example 5 here, we're going to break up the square root. So we're going to take the top one and make it a square root. And we're going to take the bottom of the fraction, the denominator, and make it a square root. Now, can I break up square root of 11? Is there any of the perfect squares we've been working on with? So it would be 4, 9, or 16 is too big. So 4 or 9, and none of them work, so square root of 11 stays the same. And the square root of 49 happens to be a perfect square, and that's 7. Now, if you look, I do not have to reduce any numbers. 7 does not go into any of the numbers up on top, and if it's inside of a square root, you can't do anything about it. So, and the square root is gone from the bottom, so this is your answer. Let's try B. Break up square root of 25 and square root of b to the 4th. Okay, so square root of 25 is a perfect square, so it's 5. And b to the 4th also is a perfect square, so it's going to be b to the 2nd. And notice I don't have any square root signs, so I leave it that way. Okay, there's another way of doing this. I could do 144 divided by 9, and that's 16. So square root of 16 equals 4. But if you want to do square root of 144 over the square root of 9, which would be 12 divided by 3, which still equals 4. So either way will work to do that answer. Okay, D. Square root of 25 p cubed over square root of q squared. Now, 25 is a perfect square and q squared is a perfect square, but p cubed isn't. So, we have to break up 25 p cubed. So, the perfect square of 25 is 25. And the perfect square of p cubed is p squared times p. I have to break up the p's. And the square root of q squared. Now I could do it. So I'm going to break up the top part. So square root of 25 is 5. And square root of p squared is p. And then left over is square root of p. And then the square root of q squared is q. And there's your answer. All right. E. I'd like you to try it on your own and see what you come up with. Put me on pause and try it out. All right. So the answer is 5 square root of 3 over 4t. I know that how that works is I could break up 75 and I could break up 16t squared. That's a perfect square, so I could get it right to 4t. But for you, if you're like, oh my goodness, how did I not get the top correctly? So square root of 75 will be turned to 25 times 3, and then you have 4t on the bottom. So then you can get this answer. All right, let's go to example 6. Okay, so this time we have imperfect square roots, but this time on the bottom, so we are going to reduce ahead of time as much as we possibly can. What can I reduce? What can go into each thing first? So, what number can go into 88 and 11? Well, 11 can. So I'm going to divide by 11 on both of them. So it's going to be the square root of 8. Now I could break up 8. Square root of 8 is 4 and 2. So square root of 4 is 2, square root of 2. So I broke up 4. B, what number can go into 12 and 27? First we'll do those numbers. Well, 3 can. So it's going to be A. We'll do the A's in a second. And 9. And then there's an A on both the bottom and the top. So I could take away an A from each of them. So the top would have 2 A's and the bottom would have no A's because I took 1 A away from both. Now I could break it up. So I have 4A squared on top and 9 square root of 9 on the bottom. So they're both perfect squares, so it would be 2A over 3. Okay, let's look at 90, square root of 90. So I could divide those. 90 divided by 5 is square root of 18. That's a perfect, not a perfect square, but I could break it up into. So square root of 18 could be broken up into 9 and 2. Going to break up 9, so it's going to be 3. What's left over? Square root of 2. Ooh, this one's going to be a little bit more difficult. The numbers that could go into 75 would be like 5, 25, and I know 3 can go into 75. So 3 could go into 75. Let's see if 3 could go into 48. Yes, it can. 3 can go into 75 25 times, and 3 goes into 48 16 times. Now I have square root. Square root of 16 over the square root of 25 would be 4/5. And leave it like that. Don't turn it into a decimal or anything like that. I'd like you to try E by yourself. Alright, so I divided 27 times, divided by 3, which is 9. And I subtracted, took away an x because there was an x on, x's on the top and an x on the bottom. And so I took one x away, so it became x squared. So 9x squared, square root of that, they're both perfect squares, so it's 3x. Now it's a little different. We have square roots on the bottom that are not perfect squares, so I'm going to turn them into perfect squares. So what do I need to multiply 5 by to make it a perfect square? Well, for that one, I'd say 5. So I'm going to multiply both the top and the bottom by square root of 5. And I'll show you what I mean by that. So 2 times square root of 5 is 2 square root of 5. And then square root of 5 times square root of 5 is square root of 25. Now it's a perfect square. That's the reason why I did that. And I'll show you when it does not have to be that number. So square root of 25 is 5, and then 2 square root of 5. It just stays that way. Cannot reduce this 5 in the square root of 5 because they're both not outside the square root. Okay, B. I have 8 in, but I don't have any squared. So what do I multiply 8 by to get me my closest perfect square? Well, my closest perfect square is 16 from 8 that 8 can go into. So I can multiply that by 2. And then I have n. I need to multiply what to make it n squared? Well, another n. So if I multiply the bottom, I have to multiply the top. That's the reason why I multiplied the top and the bottom on A. So it would be, they're both inside square root, so you multiply them together. So it would be 14n over square root of 16n squared. There is no perfect square that goes into 14, so it's just 14n. And then square root of 16 is 4, square root of n squared is n. Okay. You could do it differently. Let me show you the other way. I'm going to bring it down over here and make it purple for you. Okay, so I rewrote it again so you could do it a different way. You could just multiply what is on the bottom of the square root by itself. So I could just do like I did on example A, and I did square root of 5 times square root of 5. You could also do the same thing. You could do square root of 8n and square root of 8n. So you would have 64n squared, square root, and square root of 56. Can't spell 56 right. 56n. Now I could break up 56n, and I know that goes 4 goes into it. So I'm sorry, I have to bring it down. So it would be 4 times 14n over, I'm unsquaring this immediately, so it's 8n squared. Square root of 4 is 2, square root of 14n, and then 8n squared. But I can reduce 2 and 8. That becomes 1, and that becomes 4. So it's 14n, square root of 14n over 4n squared. Sorry, n. I meant n. So you got the same answers on top as you did on bottom. So it depends, whatever one you want to do. So if I look at C, I can multiply 18 to get close to the closest perfect square is 36. So I'm going to multiply that by, I believe, 2. 18 times 2 is 36, yep. So I need 2, sorry. 2t, because t is not a perfect square yet. So square root of 2t on top. Again, you can multiply by 18t and go through and reduce if you want to. So that's going to be square root of 10t over 36t squared. So 10t, because square root of 10t, there's nothing you could break it into, and that would be 6t. Again, you can't reduce those because one's in a square root and one's not. 7m. Well, what can I do to get rid of square? I need to multiply 10 by something to get a perfect square, and that would be 100. So I'm going to multiply it by square root of 10 on top and on bottom. So it would be square root of 70m over square root of 100. Is there a perfect square that goes into 70m? And no. So it's 70m on square root of 70m on top and 10 on the bottom. And there's your answer. All right. Okay. Goodbye.